All right, good morning and welcome back to Pre-Calc with Trig. So if you're not in the Pre-Calc with Trig class, this is going to be less useful for you, but I make a point of doing these because when I teach my calculus class, I definitely ask questions where you end up with problems like this and you have to solve these. Because I know I know students need more practice with this type of problem. So let's see if we can't get something like this on the way. So let's see here. We have 3 cosine x times tan squared x equals cosine x. We have 3 cosine x times tan squared x equals cosine x. Now, the general rule with these is you don't want to divide unless you have to, okay? So we're going to say this is 3 cosine x times tangent squared x minus cosine x equals 0. Now notice cosine is common to both of those, so we're going to pull a cosine x, and we have a 3 tan squared x minus 1 equals 0. So at this point, what we're going to do is we're going to say, well, either cosine x equals 0 or 3 tan squared minus 1, so tan squared x minus 1 equals 0. So let's work on this part. That's going to be tan squared x minus 1 equals minus a third rather, right? So divided by 3. Okay, so we're going to have tan x equals 1/3 squared x, or tangent of x equals plus or minus root 1/3. It's the same as root 3/3. Okay, plus or minus. Where is the tangent equal to root 3/3, or 1/3? Say, well, that's going to be pi over 6. You guys remember this from beginning of trig, right? And then we also have to get this in the second quadrant, which is the reference angle for this one. That's going to be 5 pi over 6. Where's the tangent positive? We also need 7 pi over 6. So we're going to need that. Okay, and then we're going to need an 11 pi over 6, because we need the reference angle for the fourth quadrant. Okay, 1, 5, 7, 11. Okay. So we also have cosine x equals 0. Where's that going to be? Okay, so that's also going to be pi over 2. How about 3 pi over 2? Okay, so we've got quite a few angles here that are going to make these statements true. Okay, so we're going to need a pi over 2, 3 pi over 2. Okay, and I don't think they ask us to do the general solution. They just have us go once around. And that's fair, because there's a lot going on here. That's generally, if I'm going to ask you this kind of question, I'm probably not going to ask you to give me all the solutions. I'm just going to ask you to give me the solutions within one rotation. If it's an easier problem, then I don't feel so bad about asking for all of them, because there's not as much to do. But in this case, we also have pi over 6, 5 pi over 6, 7 pi over 6, and then 11 pi 6. So that's pi over 6. So that's 5 pi over 6. We went 7 pi over 6. We went 11 pi over 6. All of these have the same reference angle of pi over 6. Okay, so I think that's what we have for our solution set here. Okay, and again, they don't ask us for all of them. They just ask us for, like, what is one time around? Okay, now if we did have to do all of them, I'd probably come up with a 1 pi over 2, a 3 pi over 2, 5 pi over 2, 7 pi over 2, etc. And I would group these together, make a pattern, and then I would probably group this one and this one together, then this one and this one together, and group them that way. Come up with some kind of a obscene, 2n pi kind of a expression for all of these different pieces. Okay, you can't just write ... because there's no obvious pattern here. Okay, so I'll do that to somebody. Okay, so the solution set here, and we'll go off and we'll say, okay, well, that's pi over 2. So pi over 2, comma, I want that comma. I want pi over 2, pi over 2, 2. There we go. And then 3 pi over 2. 2. And then comma. And then we need this, all of this mess. So we need a pi over 6. 6. We need a 5 pi over 6. There's 5 pi over 6. We need a third quadrant one because we need the other positive one. Oops, I want over 6. I don't want over 3. We need a 7 pi over 6 for one of the negative ones. That's still one of the positive ones, just positive in the third quadrant. And then for the fourth quadrant, we need 11 pi over 6. Okay, I think those are all of the answers that we have for this particular problem. Okay, so let's go ahead and check it and see how we did. Okay, so yeah, there's one, yeah, first quadrant, third quadrant, second quadrant, fourth quadrant, and then where is cosine equal to 0? That's at the 90 degrees, and then we'll check those. Still don't think it. Added some incorrect ones. Go ahead and say recheck and try again this thing. You know, done this problem twice now, and I think they are, I don't think that the answers that they have are correct. They keep missing the cosine one. So if you guys are doing this problem and trying it, try it independently of what my attempt was. But I think they missed the cosine. So the second time I did it, they also missed the cosine once. Okay, so we have 0 equals 0, 0 equals 0. I think they divided, I think they just forgot. So we'll call that one good, and I'll do what I can with it. But chances are, I think they forgot the cosine part of this one. Okay, so thank you for tuning in. And, we'll get you in the next video. So thank you very much, and I will see you next time.